Hey, this is Mr. Janes. In this video, we'll be talking about how to use two-way tables and Venn diagrams to calculate probability. We'll be using the example from the previous video, Introduction to Two-Way Tables and Venn Diagrams, that was done by Sal Khan of Khan Academy. If you haven't watched that yet, please watch that first. If you have watched it, you should have all of these different values from the Venn diagram and two-way table already filled in. Now, a probability is the chance that something will happen or how likely it is to occur. We're going to talk about different kinds of probabilities here, such as basic, not, and, or, and conditional probability. For each one, we'll start with a specific example, then back up and talk about the details of how to do that kind of probability, and finally end with one last example that you'll try on your own. So let's start with basic probability here. What is the probability of choosing a chocolate candy? Let's go back up to our Venn diagram and two-way table to help us figure that out. Now, every probability starts off as a ratio or a fraction. In this case, we're going to look at the number of chocolate candies over the total number of candies. So, look at the Venn diagram first. Within the chocolate circle, we can tell that there are 6 plus 3, or 9 chocolate candies, out of a total 6 plus 3 plus 1 plus 2, that's 12 candies total. So that's 9 out of 12. We could also use the two-way table. How many chocolate candies are there? Well, it tells us here there's a total of 9 chocolate candies. Again, that is 3 plus 6. Out of a total of 12 chocolate candies. So either way, using the Venn diagram or the two-way table, it seems like there's a 9 out of 12 chance of picking a chocolate candy. Let's write that fraction down below. So we found the probability of choosing a chocolate candy was 9 out of 12. Now, we often like to reduce our fractions to simplest form. So 9 out of 12 reduces to 3 out of 4. Now, sometimes we'll want to write our probabilities as decimals. Now, a probability as a decimal is always between 0 and 1. To get there, all you need to do is divide the numerator by the denominator, either by hand or in a calculator. Now, 3 divided by 4 gives us 0.75. So the probability of choosing a chocolate candy is 0.75. Now, sometimes people like to see those as percents. To get from a decimal to a percent, all you need to do is multiply it by 100. So there's a 75% chance of choosing a chocolate candy. So let's review those 3 ways of expressing the chances of getting a chocolate candy. First, we used a fraction, where we put the specific number of outcomes in the numerator and the total number of outcomes in the denominator. Think how many we have out of the total possibilities. In this case, it was 9 out of 12. We also created a probability, which is a decimal between 0 and 1. Remember, to get from a fraction to a probability, all you need to do is divide, either by hand or using a calculator. Lastly, we created a percent. A percent are the chances something will happen with 100% as a maximum certainty. To get from a probability to a percent, all you need to do is take that probability and multiply by 100. Now, there's a lot of information here, and if you feel like I'm going too fast or you can't write things down, feel free to pause, slow down, rewind, and rewatch things as you need. Now, there's one last thing to know about basic probability, and that's how it is notated. Now, we could keep writing things like, what is the probability of choosing a chocolate candy over and over, but in math, we like to be precise and shorten things. So there's a special way that we write down probability. Let's say something happened called A. Instead of writing the probability of A happening, we could write it like this, P parentheses A, just like that. That means the probability of A. So if I wanted to go back to our previous example, what was the probability of choosing a chocolate candy, I could have written P of chocolate, close parentheses, and that is the shorter way of writing the probability of choosing a chocolate candy. Now, if I wanted to represent the probability of A happening on a Venn diagram, remember that's everything inside the A circle. If I want to represent it on a two-way table, that's everything in that same row or column as A. Now pause here and try and find the probability of choosing a coconut candy. Please find the probability as a fraction, a probability decimal, and a percent, all 3 ways. Pause the video now. Next, let's talk about not probability, or the probability that an event does not occur. Just like last time, let's start with an example. What is the probability of choosing a not chocolate candy? To figure this out, the Venn diagram and 2A table will be able to help us. Now, to figure out which candies are not chocolate on a Venn diagram, look at the chocolate circle and choose everything outside of it. That will include the one candy that was coconut but not chocolate, and the two candies that were neither coconut nor chocolate. On a 2A table, just identify the row that is chocolate, and then take a look at the rows that are not chocolate, all the other ones, which happens to be these three candies right here in total. So either way, there are three candies that are not chocolate out of a total of 12 candies, whether you look at the Venn diagram or at the 2A table. 3 out of 12. So the probability of choosing a not chocolate candy, we said that's going to be 3 out of 12, which as a fraction is equivalent to 1/4, or as a decimal, we can divide and get 0.25, and as a percent, that's 25. So there's a 25% chance of choosing a not chocolate candy out of all of those candies. Now, what about the details of not probability? Turns out that not probability, or the probability that something doesn't happen, is also called the complement. Now, just like before, we've got a shorter way of writing the probability of not something happening. So the probability of not A is written P in parentheses A with little c up here as a superscript, almost looking like an exponent. That C stands for complement. So what would that look like visually? Well, this is something we've already done. If I wanted to shade the complement of A or not A, remember, that's everything outside of the A circle on a Venn diagram. That's including everything in any other circle and everything outside of both circles. On a 2A table, I look for the rows that are not A, and I'll highlight those. Now, there's one other thing about not probability or complements that you may have noticed. The probability of choosing a not chocolate candy was 25%. Remember from the first example, the probability of choosing a chocolate candy was 75%. If we add those together, we would get 100%. And that always happens. The probability of a certain event occurring plus the probability of that event not occurring, or the complement, is always 1 as a decimal, or 100%. So instead of trying to figure out the probability of choosing not chocolate candy by looking at the Venn diagram and 2A table, I could have just gone back to the previous example, taken the 75% probability of choosing a chocolate candy, and subtracting that from 100% to get that the probability of choosing a chocolate candy complement is 25%. So let's take a second to answer this last question. What is the probability of choosing a not coconut candy? Remember, your answer should start with the probability of coconut, with this little c up here for complement. Then write the fraction, the decimal, and the percent that gives the probability of choosing a not coconut candy. Remember, you could do this by either using the Venn diagram and 2A table from before, or by taking your answer to the previous set of examples, what is the probability of choosing a coconut candy, and subtracting it from 1.